can't get the bases to be the same. So the first thing I look to see is if I have e's or I don't have e's. Okay, and in this case, I have an e. So what works? Who's e's best friend? Can you guys tell me in the chat, who's e's best friend? What do we remember from last week? Who's e's best friend? Not F, Cole. Thank you, though. I appreciate it. There we go. It would be F or D, right? Okay, it's natural log is e's best friend in math. Okay, maybe in English, F is e's best friend, but in math, it's natural log. Okay. All right, so what I'm going to do is I'm going to take the natural log of both sides because I know that it works well with the e. So I'm going to rewrite it as natural log of e to the x equals natural log of 72. Okay. Then we're going to go ahead and we know our e and our natural log cancel and we get x equals natural log of 72. In the last half of the lesson, I recorded it before I assigned the homework. And it turns out that we need all of our answers in decimal today to get them into WebAssign. So you will get enough in this first half of the lesson, getting them into decimals, that you'll be able to do that for the second half of the lesson. So just know that you're going to have to go to decimal point for all the WebAssign stuff. So I'm going to have to keep flipping back and forth here. I'm going to go to Desmos, and I'm literally just going to type in natural log 72. And you're going to go 3 decimal places for the answer. So it looks like 4.277 is what I want for that answer. So 4.277. And I believe WebAssign wants you to go 3 decimal places as well. Okay. I'm going to give you a couple seconds to finish that one off, and then we'll look at example 9. Okay, so on example 9, you want to get everything off the exponential before we can take the log or the natural log of both sides. So I am going to, let's see if I can do this without flipping a bunch. So I'm going to divide both sides by 3. So we get 2 to the x equals, is it 14? Double check my arithmetic. 3 goes into 4 once, 3 goes into 12 4 times. I think we're good. Now, what I have to solve for is up in the exponent. Okay, so whenever I see that, and I cannot get, there's no way for me to write like 2 to the 3rd and get 14, right? Or 2 to the 2nd and get 14. That doesn't work. So when I see that happen, I can't write the bases the same. I'm going to take the log of both sides. So solving for an exponent. An exponent, take the log of both sides. Your clue, again, is you don't have any logs in the equation to start with. And it doesn't matter which log I take. I could do the common log, I could do the natural log, I could do log base, whatever. Typically, we use the common log. So I'm just going to do log of 2 to the x equals log of 14. Now what we are going to do is we're going to take that x and we're going to use our log properties, allows us to expand it and move it to the front. That's how I get it out of being in the exponent. So we get x times log of 2 equals log of 14. Now, I know log of 14 and log of 2, they're numbers. I'm allowed to put them in my calculator, and they're a decimal point number. It's ugly. If I was to put them in decimal point right now, we're highly likely that we're going to write down something wrong. Okay, so what I'm going to do is I'm going to divide it using the logs, and then we'll put it in our calculator. So I'm gonna do the inverse operation on the log. So divide by log of 2 on both. So I get x equals log of 14 divided by log of 2. And then we're going to put that in our calculator. I'm going to give you a minute to write, and then we'll put it in the calculator and see what happens. And I need to ask some questions because it's been very boring just listening to Mrs. Ballard, I'm sure. All right, so we've got log of 14 divided by, oh, look at what happened when I did divided by. I might want to do parentheses log 14. And then I hit the slashy for divided by log of 2. That was right, right? Yeah. So we should end up with 3.807. 3.807. Make sure you're practicing in decimals, because remember, when it comes time for the test, on this problem, I will have the Desmos calculator show up for you, okay? And I'll probably give you the graphing one, even though I think I have a choice of the scientific. I'll probably throw the graphing one there. You don't need the graph, but then you've got all the functionality that you need. All right, let's take a look at example 10. So the first thing I need to do on example 10 is I need to isolate that e to the x. So what do I need to do to get that e to the x by itself? Can you guys tell me that in the chat? Here's where I'm going to ask questions. What am I going to do to get that x or that e to the x by itself? Help me out.
Add 5 to both sides.
Okay. Matthew says we got to add 5 to both sides. Everyone else is seeming to agree in the chat. Good. So we haven't forgotten our algebra skills. So I'm just going to go ahead and do that. E to the x equals, I'm going to add 5 to the 65 or to the 60, and I get 65. Now, what do I need to do to both sides to get the x out of the exponent? Am I going to use log or am I going to use natural log? Can you tell me that in the chat? So log or natural log? All right, nice work. We see an e, we're going to use a natural log. So the natural log of e to the x equals natural log of 65. The e and the natural log cancel because we planned it that way. Equals, and I'm just going to go ahead and go to my Desmos calculator. I'm going to type in natural log of 65. 4.174. So 4.174. I'll give you a couple seconds there. All right, so here's what I want you to do next. There's almost no difference between 10 and 11, okay? I want you to take a minute. It's 9:27 on my clock right now. At about 9:29, I will start talking again. Please try 11. Don't type anything in the chat till I say to, okay? So everybody try 11 right now. All right, go ahead in the chat. Tell me the answer you got. Okay, so tell me the answer you got in the chat. Some of us are ready. I'm gonna start working it. So we've got e to the x equals, let's say I add 7, I get 30. And then we're gonna natural log both sides. Okay, and it looks like most people are getting 3.401. So let's double check that in Desmos, right? I'm gonna flip it again. It was natural log of 30, right? Did I do it right? 3.401. All right, nice job, everybody. Okay, so let's move on to something a little bit different, a little bit tougher. And the last few here. I think I gotta go, yeah, I gotta go to 17. Okay, so notice this for this type of problem, 12 and 13 are as hard as we're gonna get, okay? So we are going to, we are going to try to isolate the exponent, okay? So that's my first job, is to isolate that exponent. I'm gonna move it because I just lost one note. I gotta do a lot more writing on this one. Okay, so I'm going to start by adding the 4 to the other side. So we've got 2 times 3 to the 2t minus 5 equals, let's see, 15, right? When I add the 4 over. And of course it would be an ugly decimal point, wouldn't it? So 3 to the 2t minus 5 equals 15 halves, or 7 point something, right? 7.5. Now, I have no logs. I definitely am not going to write 3 as something to get 15 halves, okay? So what do I need to do to both sides of the equation? Can you tell me what I need to put on both sides of the equation in the chat here? What do I need to put on both sides of the equation? What do we think? Think back to what we did on example 9. So what do we need to do to both sides? All right, nice work. We're going to have to take the log of both sides. And it's going to be ugly, you guys. It's going to be ugly, okay? So we've got the log of 3 to the 2t minus 5 equals log of, I'm just going to write it as 7.5 for lack of anything better, because I don't want to keep writing the fraction. I'm being lazy. All right, I now need to take this exponent and I need to move it to the front. And there's going to be a lot of algebraic manipulation going on here. Okay, so now it's 2t minus 5 times log of 3 equals log of 7.5. There are a number of things I can do from here. Okay, I could divide the log 3 over and then add 5 and divide by 2. That's an option. Okay, the other thing I could do is I could distribute this log in. So I'm going to go that route. And again, like I said, there's more than one way to do this. I'm going to go that route and see what happens. So 2t log of 3 minus 5 log of 3 equals log of 7.5. My goal is to isolate the term that has the variable in it, which is going to be the one that has the t. Okay, so this thing here is just an ugly number. I'm going to move that ugly number to the other side. So I've got 2t log of 3 equals log of 7.5 plus log of 5, sorry, plus 5 log of 3. All right. Plus 5 log 3. Making sure, oh good, I wrote all over the desk. Log 7.5 plus, I'm trying to write it down so I know what to put in my calculator. All right, now 2 and log 3 are just numbers. They just sort of look like they're in a weird spot. Okay, so I'm going to take those numbers and I'm going to divide them over to the other side. So what I end up with is t equals log of 7.5 plus 5 log of 3 divided by 2 log of 3. We're going to put that whole thing into our calculator all at one time. Okay, so I'm going to give you a minute to write, a couple more seconds to write down, and then we're going to type it into Desmos. Okay, and you need to practice this. And if you need more space, I'm looking at number 14. We're going to get rid of number 14. We're going to skip it. Okay, I didn't assign any like it on the homework, so we're going to just get rid of it. So if you need some more space, we'll do the rest of them, but 14 is unnecessary for where we're going. It's a good problem, but we'll give factoring a rest. It's Monday, right? Because I got a factor on that one. All right, here we go. I'm going to clear out my Desmos here a bit. Okay, so I know I got to do log of 7.5. Now, Desmos gets kind of funny. Sometimes, oh, I needed parentheses probably. Probably parentheses is a better way to start that. Log 7.5 plus 5 log of 3. Close my parentheses, hit the slashy fraction, right? And then I've got 2 log of 3 in the denominator, and there is my answer. All in one nice, clean, put it in from, put it in the calculator one time. Okay, so much better than having to write down, figure out all the decimals, write them all down, and then divide it all out, where I'm probably going to make a mistake and my answer might not be as accurate, because what if I don't keep enough decimal places? Okay. All right, so let's write that answer down. So it was 3.417, is that right? 3.417, perfect. All right, here's what I want you to do, okay? It says 35 on my clock. I'm gonna give you till 37. Get as far as you can. Don't put anything in the chat till I tell you, okay? I want you to try 13. It's identical to 12, just different numbers, okay? So everybody take a minute and try it. A really long 37. I'm going to go about 30 or 40 more seconds. I just turned 38. So about 30 more seconds, and we're going to go over it, okay? All right, I'm going to start it, and then I'm going to ask you questions along the way, which you should be ready to answer, right? So I might not be asking the answer yet first, so don't put the answer in yet, okay? So I'm going to start by subtracting the 4, right? I'm going to put my work off to the side so I have space for it. So 2t plus 5 equals 7. And then I'm going to divide by 6. So this one I probably would have left in fraction form because I can't easily divide 7 by 6 in my head. But if you did that in your calculator and you want to write the decimal down, that's fine. Okay? All right. What do I need to do to both sides from here? Can you guys tell me in the chat? What do I need to do to both sides? What'd you do? All right, nice work. We are going to take the log of both sides. So log of 2 to the t plus 5 equals log of 7 over 6. Okay, what do I need to do now with the t plus 5? Where do I put that? Where do I put the t plus 5? All right, we want to take it and we want to put it in front. please, and I know I didn't say this before I did it, but I didn't say it. You need to put parentheses around that every single time, okay? If you don't, what's likely to happen is, don't write this down, you will get something that looks like this, t plus 5 log of 2, which looks like you're doing 5 log 2, totally different than distributing it, okay? So this is a no-no. All right, don't do that. Okay, I already said distribute, and so I'm gonna do that part. T log of 2 plus 5 log of 2 equals log of 7 divided by 6. All right, what do I need to do next? What do I need to do next? Can you guys tell me, describe it to me in the chat. You guys are doing great. So great. I hope you all signed up for calculus next year. So I'm super looking forward to it. Okay, so we're going to take this and move it to the other side. We've got t log of 2 equals. I'm subtracting that over. It doesn't really matter if I put it in the back or the front. All right, and then I need to divide by this number log 2. I didn't have another coefficient with it this time, so that's okay. Not a big deal. If we have the other coefficient, we move that too. So it looks like t log of 7 divided by 6 minus 5 log 2 divided by log 2. Okay, so hopefully everybody got that part written. All right, do me a favor. Tell me what you got as your final answer in the chat. What did you get as your final answer in the chat? I'm going to start putting it into Desmos so we can check it. But everybody tell me what you got. That shows me that you did the work we needed to do to get to the end. All right, we ready? Let's see. Negative 7.778. I'm seeing a lot of that here. I'm going to put in that final number. And guess what? Negative 4.778. I did see one or two that popped up with only 2 decimal places. Remember, we always go 3. When I believe that WebAssign is doing 3, and when we go in and like do the practice for our test, it will grade it at 3. My test will grade it at 3. So make sure you're accurate to 3. Okay, you may round at 3. So we end up with t equals negative 4.778. All right, we're going to start the next kind of set of stuff together, and then you're going to end up finishing it on video here. But we're going to kind of see a little bit of it together. We are going to solve, and now we have logs in the equations, okay? Just like we did last week a little bit. So again, when I don't have a log in the equation, I want to take the log or the natural log of both sides, okay, if I can't get the bases equal. So I have to reverse in number 15, I have to reverse a natural log, okay? We learned a really fancy word last week. Does anybody remember the really fancy word for what we have to do to this? Who remembers the really fancy word? It starts with an E. Oh my goodness. Nice work, everybody. You guys are awesome. Okay, so we are going to do what we call exponentiate. And remember, I told you this is important. In about a year from now, maybe less, we use this heavily in calculus. Okay, we exponentiate both sides, and I expect to, you guys are so good, I expect to hear that word next year. Okay, so e to the natural log of x, 3x equals e squared. At AP Readiness on Saturday, we even did this. So it comes up, it keeps coming up. All right, e to the natural log cancels, and we get 3x equals e squared. And I'm going to go ahead and divide by 3. I get e squared divided by 3. Now remember, I told you that in my video, I didn't simplify any of it into decimals. We are going to in this part of our notes, because that's what WebAssign is going to do to us. So we had, I believe it was e squared over 2, right? So you just type in an e, you hit shift and the 2, And then it was divided by, let's see, I totally forgot, 3. Divided by 3. So 2.463. 2.463. Okay, so 2.463. All right, we have talked a little bit about what happens with example 16. When I have the logs and I have a single log on each side, what happens with the logs? Do you guys remember? Can you tell me in the chat? What happens with the logs? When I have a single log on both sides and they match, what happens? Nice work. They cancel out. Good job. So we get to cancel those out. It's technically called the one-to-one property, right? 5x minus 1 equals x plus 7. We're going to subtract the x to the other side, so I get 4x. And I'm going to add the 1 to the other side, so I get 8. And then we're going to divide by 4. So I get that x equals 2. And I should have really checked this one, but I do need to double check to make sure when I plug this into these that I don't get a negative inside. 5 times 2 is positive 10 minus 1. That works. 2 plus 7 is going to be 9. That works. I don't need to write it down. I just do a mental check. And then you will see some when you go through the second part of the notes that that don't work. Okay, so we have an extraneous solution. There might only be one solution. I believe there's maybe one in the homework that comes up no solution because both of them are extraneous. Okay. I want you to scroll down to the very end because I realized after I had done all the videos for the notes that I made a mistake, okay, in the video. So we're going to write this out now instead of later in the video. When you see the video, what I said here was completely wrong because I didn't teach that part of the lesson. I totally blanked in my brain that when we have no logs and we're solving for the exponent, we're supposed to take the log of both sides. So that's what should be written there. We're going to take the log both sides. Okay. And then some other things to remember. We'll just go through these right now, and then you don't have to do that part of the video. Okay. So if we have one log on one side, we use the log loop. Okay, and we've seen that in action. You're going to see that a little bit more in action here in the last part of the lesson. If we have one log on each side, we cancel the logs, which really means we're using the one-to-one property. And then if more than one log on one or both sides, and we haven't seen that yet, but you're going to see that in the next part of the lesson, you condense first and then apply another property. So basically that means you might have to condense it and then maybe it's a log loop. Or maybe you have to condense it and then it cancels on both sides. So once you do this one, you're going to have to revisit these two, okay? Or actually any of these two. Any of those two, not the top one, typically, okay? I'll leave that there a minute. Again, the one that's most important is make sure you get the first one down because it's wrong in the video. Okay. Though if we do have the bases the same, we would cancel the bases. That part's true. It's just that that's not what I was trying to get at. Okay. Before we do our joke of the day, and I'll leave it there for another minute, I decided that Pi Day, one day was not enough. Okay. So that I figured we should just celebrate all week long, okay, with Pi Day activities. Unfortunately, we're not together, so they're kind of virtual Pi Day activities, and we can kind of keep watching them throughout the week, okay? There are some contests. There's extra credit out there for this, so the more you participate in, the more extra credit you can earn. And it's a little bit of extra credit, enough to make it worth your time, and to hopefully get you a little bit creative in math. Has nothing to do with what we're doing in class. And it's meant to be just to have a little bit of fun, okay? But math fun, right? No, I know math is fun.